Okay, everybody, so here is the lesson 17 problem set. I'm just going to focus on drawing two parallelograms with some of the attributes. So I'm going to focus on doing C and D, and then I'm going to do question 4 because I think question 4 it's really important that you're able to talk about parallelograms and what makes something a parallelogram and when is it a trapezoid and when is it not, or is a trapezoid a parallelogram, because that's kind of what this entire topic is about, is being able to talk about the differences and what makes a shape what and why. Okay, so I'm going to go back over here. So I'm going to draw parallelograms, and the first one says my parallelogram needs to have equal sides with no right angles. So that's going to look a lot like the one that I drew earlier. So let's see if I can do this. I like to line things up. Okay, so I'm going to try and do a side length of 2. Side length of 2. And actually, I think I'm going to go outside of this box. Length of 2, and if I've done this right, then this should also be a side length of 2. That means my angles would be right, and I have a feeling, there we go. Oh, almost perfect. Okay, so equal sides with no right angles. So these should all be right around 2 inches. And if I measured these angles, which you know I'm going to do, that's 110. If my angle was correct, which I think this one's off, this one should be about 70. And then I should find that my other two angles are also 110 and 70. But like I said, I was a little teeny bit off. That's 110. We're going to call it pretty accurate though. And 70. Okay, so this would represent equal sides, no right angles. And we know it's a parallelogram because I have this 70 degree and this 110, and then I have this 110 and that's 70. This is going to equal 180. This equals 180. Okay, so now we have all sides equal with at least 2 right angles. So I'm going to make this easy on myself. Since it can have at least 2 right angles, then I'm going to make all of my angles even. Okay, so I'm going to start. I'm going to do 2 inches. Okay. And now I really want to make sure this angle is correct. So I'm just going to go up to 90 degrees. So that way when I come and draw my line, and I do my 2 inches, I can line it up. Line it up right there. Okay, so that's 2 inches. That's 90 degrees. I'm going to do the same thing over here. So I'm just marking out 90 degrees the best way that I can. So that way when I draw my 2 inch line, and I could even do this, I could put this on the 1 inch, and I know that 3 inches, from 3 inches to 1 inch is going to be my 2 inches. Okay, and then I'm just going to finish this. All right, so now I have, that's 90 degrees, that's 90 degrees, this is 90 degrees. I have 4 equal sides that are all 2 inches. And my little square that denotes, that's the universal sign for 90 degrees. We know they're 90 degrees because I pre-measured before I even drew them. And so we know that we would have this angle and that angle that equal 180, this angle and this angle that equal 180. Okay, so parallelograms, angles, and two sets of parallel sides. So I'm going to flip over, okay, and I really want to look at question 4. So question 4 is, list the properties that are shared by all of the parallelograms that you worked with today. So remember, properties is just a way, this is really like, what did we learn about them? In order to be a parallelogram, what do you have to have? What did we learn? What does a parallelogram have to have? Okay, so I hope that the first thing you would list is parallelograms have 4 sides. Because a parallelogram is a quadrilateral, right? We know it has 4 sides. This was the big key thing that helped distinguish a parallelogram. They have 2 sets of, I want to write it like this, 2 sets of opposite sides that are parallel. That's what we learned in that first video. We also learned they have opposite angles that are equal, so that are the same in measure. That's how we end up with those 180 degrees, because they have opposite angles that are equal. We learned that the diagonals bisect each other. And then we also learned that opposite sides are equal lengths. Okay, so the reason that I wanted to go over this and really look at these attributes is because at some point when you're assessing what you know, you're going to have questions that ask you, is this true? Is this false? Does a parallelogram have 2 sets of opposite sides that are parallel? Yes. Diagonals, parallelograms do not have diagonals that bisect each other. False, because we know it's true. The diagonals bisect each other. So it's important to kind of have this working information about what makes a parallelogram a parallelogram. Okay, so when can a quadrilateral also be called a parallelogram? Okay, so a quadrilateral is also a parallelogram when it has 2 sets of opposite sides that are parallel. So a quadrilateral can also be called a parallelogram when it has 2 sets of opposite sides that are parallel. When can a trapezoid also be called a parallelogram? So in order for a trapezoid to be I should put to also be. Because remember, shapes can be more than one thing. To also be a parallelogram, it must have two sets of parallel sides. And again, that's opposite sides. So I want to show you something, okay? So I want to show you how this is true. So I have a picture, and this is where we'll end for today after this picture. Okay, so in this picture, this is the hierarchy of these shapes. So here's our umbrella. Everything that we're going to talk about is a quadrilateral, okay? So quadrilaterals include trapezoids, okay? Here, there's a trapezoid that has at least one set of parallel lines. And parallelograms are also trapezoids because they have at least one set of parallel lines. What makes them their own shape is that they go past that one pair of opposite sides that are parallel, and they have another pair, okay? And this is kind of why all parallelograms are trapezoids, but not all trapezoids are parallelograms. Because if we look even at this trapezoid here, and I mentioned this in one of the earlier videos, this trapezoid that's drawn cannot be called a parallelogram because it only has that one set of parallel lines. Okay, so this is, when we talk about shapes, it's very precise. So we'll keep learning with some new shapes as we get further into the lessons. If you have any questions, please send me a message. Thanks.